Oh, we mentioned this bypass module. That's right, we have another module on this. As you can see, it's got just 2 wires going through it. Those wires are coming from the input and output jack and going to the tube circuit. Why would I do that? So I could build a relay module. That's right, relay, switching. This is a stomp box after all, or at least a reasonably drawn facsimile of one. We want to be able to turn it off and on. Now I won't be adding an actual foot switch jack to this again till my parts come in, but I can still build the regulator module, get it ready, and set myself up to manually switch it on and off. So much like in the design of this module, we're going to be using one of these hobby boards. I've already kind of fitted a switch on it, and then I'm going to show you how I mount it to this socket. Now I've been in the prototyping stages today, trying to figure out exactly how this particular module is going to work. So we bust out here the good old trusty breadboard and plop that down. Now I gotta go ahead and hook this up. We'll get these connected onto our AC supply. All right, we'll turn it on just to get the juices flowing. We got ourselves an indicator light. Channel indicator, if you will. Oh, pretty straightforward. She clicks, she clicks. Now, if you take a close look, you're gonna see all sorts of components, specifically 2 transistors. This isn't your standard just plain relay. There's a little bit more going on here. It's transistor buffered. The idea being that the transistor buffer can leverage the artificial center tap in such a way that, you know, all we gotta do is touch anywhere on the chassis and boom, it switches. That way, our stomp box, our actual foot pedal, can be grounded to the chassis, so that will eliminate any margin of error. It's only going to be passing a very low signal current. Don't have to depend on it to actually do any load bearing, and then boom, the circuit does the rest of the work. And it's actually quite a simple circuit. Well, at least simple depending on your definition of simple. We have AC coming in here, halfway rectifier. We got 2 270U capacitors doing our incoming filtering. Again, because I scrapped them out of parts. And then that goes to a 4403 PNP. The PNP switches positive. So we got our positive rail here. And then we have our relay down here with a flywheel diode. That's so when the relay kicks off, the collapsing magnetic field will send an inverse polarity of shock wave through the circuit. It can just ground itself out through there. 100 ohm. The relay that I'm using is 5 volts, 30 milliamps rated. And I found after some calculations that a 100 ohm resistor is perfectly what I need to bias that relay the way I need it. To actually control the transistor on the gate, we got a 10K tied to positive. You see, a PNP transistor, positive turns it off and negative turns it on. It's turned on by negativity. And that's what we have here. That 1K connects to the input. You know, you just ground that out. Because of a center tap, we have both negative and positive potential to this circuit in that ground chassis connection. So it's pretty much just gonna take what it needs, and you don't even need a diode. The PNP's at positive potential. It's going to detect the negative potential here. We have a 1 UF capacitor polarized. The negative is on this side, and we need that to stabilize this because there's going to be certain ripples and whatnot. The center tap is based on AC after all. That will stabilize that input to make sure that this guy fires properly. Now, on the output over here, that's firing the relay. In series with it is the indicator that tells you when the relay is on. That would be, in this case, the yellow LED. And then it goes over to the second transistor. That's another of those PNPs. It is tied to negative so that it stays off, except when this transistor turns this circuit on, it sends positivity through here that will turn it off. This diode right here makes sure that backflow doesn't go in here and interfere with what's going on. Meanwhile, all this guy is doing is controlling that indicator LED, the red one that's on right now. 470 ohm resistor biases that LED and it just works. Sometimes you might need a resistor here, but according to my tests, I didn't. And even if I added one, it was still pulling the same amount. You typically need a resistor on the gate input of a transistor to set the amount of bias current to actually turn it on. Otherwise, if you allow the potential on the gate to be higher than the potential on the input, it it could cause the transistor to actually draw load from the gate and overload it. It's all basic design. So now we just have to take this and build it onto this. So that's what I'm gonna do next. If you just came for the lulz, I guess you could tune out now. But if you're here for a little bit of higher entertainment, watching me build a circuit, well, hey, welcome. One of the hardest parts of doing something like this is figuring out how to lay out the circuit. Now we want it to sit in here, and I have to get the chassis here ready so that I can see what I'm doing. So the module orientates like this, and then maybe I have it sit face forward. Either way, our target is about, it's gonna be that deep, so we gotta sit our relay. I want it to be down as far as possible because I don't want the signal lines to stick out any more than they have to. So right about there is where the relay is gonna wanna be. We might actually have to use or put some shielding. Maybe I might make something to go around this after, depending on how silent it likes to operate. So we're gonna orientate firing pins, as I call them, on the top and the signal pins on the bottom. I have it very loosely sketched out on here, what pins do what, so that'll make my job a little bit easier. But this guy just wants to float away. I'm just gonna start by tacking the relay down so that it doesn't move on me. 2 pins. And the easy first connection is to just basically bridge the far side contacts here so that when the relay kicks on, it's gonna pass the signal directly out. When the relay is off, I want it going through the overdrive. That way we don't have to worry about interference of that coil getting into the circuits. I will simply dig through rubbish bin for a little crossbar, sir. Three-handed operation. Unless can I, oh yeah, there we go. I need a smallest snip of brook. Oh, that one crossbar took a lot of effort. Whatever, it's in now and that's all that matters. Yes. Now the other guys, they're not really involved in the rest of the circuit. I'll just have wires going from them directly into the tube sockets. So that's a step that I do last. I'm actually gonna start off with a bit of aesthetic positioning. I'm gonna put the LEDs in place where I want them to go and basically adjust the circuit accordingly. It would be nice if the LEDs had a common bus, but they do not. Slow to start, but then it all starts coming together. Might as well solder this switch down. Why did I put that leg on that side? You inefficient. Inefficiency. Oh, this little friggin' diode is being a nuisance. Is he even gonna fit through these holes? Yeah, that one will. That one won't. You're just making every effort to not cooperate and get through the hole. That was nice. Hope that was something that I need soon and then have to go looking for. And I did it backwards. That's the ground side. I should probably optimize that diode out of the way. That's input trigger, so I need to jump that guy over to there. Now, do we do that on the arse end? Do these want to be 2-hole or 3-hole or diagonal hole? Oh, that could have been bad. I think we're just about done here, bud. That's an AC source in, that's an AC source in. We've got to jumper this switch over. Negativity turns it on. Negativity turns it on. So we got the negative bus here, and then we got to get the negative bus to the trigger bus. First, I think we need to see that this still works. Oh, I've been in the zone for a while there. I don't even know why I bothered to film this. But I'm at the stage, I want to see that this circuit's gonna work. So I'm about to connect power to it. So one source of power is going to be, well, there's a negative bus here, positive bus here. Oh boy, something ain't working right. Oh no, I've done something wrong. It's power in. Okay, wait. Oh, that resistor's supposed to tie to the positive bus, bud. And I tied it to the negative bus. Oh, you little. I think I can quickly adjust on that though. I wired it NPN style, but it's not NPN, it's PNP. It needs to move over here to the positive bus. Now it should not turn on, but that light should turn on. Oh, it's gonna be a pain in the ass to test, bud. Got nothing to grab onto. Oh wait, that light's on. Okay, and then if I touch this to negative. Ah, I think it's gotta work, sir. All right, now we just have to finish it. I gotta get that white wire back into place. I had to pull it to test this. Such as disappointment. Can I force it through? Can I just force it through, bud? Can I find the hole that I want it to go into? We need the other heater connection. Heater sources. That ties on to the negative bus here. I need some way to trigger this switch. Hey, why is that diode popping out? Oh, I derped out my diode. My diode ain't set right, bud. Diminishing gains, though. I'm gonna have to just leave it like that. Diminishing gains, bud. Diminishing gains. I think you know it. Trigger and ground. That's what I'm gonna do. I'm gonna take this white wire. I'm gonna bring it back around to the switch. That will select the trigger mode. Down, we'll just ground it out. Come on, get in your hole. Get in your hole. Come on, get in your hole. Oh, she's getting a bit busy. Then I need a trigger line. Ha ha ha. Pop, 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 pop. Okay, so our power connections and signal connections are all made. Yellow and green are the AC supply respectively. Black and red are the trigger signals. Black is just ground. It's gonna go to the same ground as all the rest of the stuff. And then red is the actual trigger. Now we need 4 more wires here. We gotta get these out here because these will go into the tube sockets. So I guess we're gonna have some scrap. I just gotta kind of cut these down so that I can... So I need 4 more wires just to get the signal through. So white and blue. I'm gonna use a bit of trickery because we're gonna have signal coming in from the rear, right? Right. Compromise that signal line a bit. So white and blue rear is in, and then white and blue front will be out. Okay, now we just have this messy octopus guy here that we gotta figure out how to get into a tube sockets, buds. Part of that problem is deciding what pins do what. So, to prep the tube socket, well, we first have to remove the wires that are in there right now. Now, some people might not realize this, but a tube socket, these pins, they're hollow, and you just solder into them. The real trick is getting them fully cleared out of solder. I have a tendency to do that by using a pin. You just gotta be careful because you don't really want solder on the outside of the pin. You want it to socket nice, right? Oh, this one's got a lot going on in it. Uh-oh. This one must have a lot of solder in it. Oh, there it goes. Spewing out the bottom. Okay, I think I got these mostly all cleared out. They should be able to take a wire now, except for this one. Oh, false alarm, it's good. All right, so to mount this, where is that little piton? We have this brass tube, and we drop that in there, and we figure out what we want our length to be, about right there. Nope, maybe a touch taller than that, actually. Yeah, that should be good right about there. Now I have to cut this tube. That's just generally done with a little pipe cutter. I'll use a drill to spin on it. Now we have to bring in a consultant. And that was noisy. I'm glad that's over. Okay, there, point. Oh, that was wonderful. Do you see where I'm going with this? So we have this brass rod. We line it up nice. And brass tends to solder really well. You can just do that. How slick and snazzy is that, brah? You just go ahead and do that on both sides. As we get our glue guns, we need more places to plug in things here. Now, that is gonna generally sit in there like that. We just have to size up our wires. Need to take a look at our chassis here to make sure we line up all the tubes correctly. So, signal side goes up to tubes, passes through. Gonna start stripping on these. Give them a nice twist as you pull the insulation off. So now the other wires, we'll take power from this side and we'll take signal from this side. That means these power lines, even though they want to go the other way, and signal lines will be on this side. Relay signal, that is, not audio signal. All right, so tube is generally oriented this way. We gotta try to get the wires into respective holes, even though that might not fit nice until I glue it down. So yeah, I'll glue it down, then force the wires. Oh, the heat gun's not ready yet. I'll get the heater wires ready. Grab some yellow, grab some green. Get them in the drill. And hey, tighten them up right nice. You want to twist your heater lines, but you don't want to twist your signal lines. I see some people build amps there and they have all their wires twisted. No. You see, this helix pattern allows the currents to kind of create induction where certain similar signals in the wires will cancel each other out. Now that's good for the heater, but not good for the signal, right? Do we have heat gun yet? Oh, you're still not there. Right, well, let's get those heater wires in place. I am not sure which way I want to run them though. I need them to stay well clear of the signal. So it's like, do I prioritize the sensitive over here or do I run them this way? My plan was to run them this way. Green front, yellow rear. See if we can get those in there. Just don't go putting any normal tubes in here. The signals or pins might not line up, but oh, I'm running on fumes. I'm gonna have to run out and buy more solder tomorrow. All right, let's see if we can't route this nice, bud. Get it like right out of the way. Sucks it's intersecting that ground wire already and intersecting with the DC heaters out front here. Actually, I don't even want it at the bottom of the chassis. I'm gonna bring it up and around here. You have to think fourth dimensionally. Get that tacked up. While I'm in here riding this wave, I might as well get the last couple of connections finalized. There's no signal wire yet, so I don't have to worry about that until I actually install a foot switch hole. So I just need to connect one more wire in here, which is going to tie it to the ground bus. I need to route this wire. Come on. I need to get it's gonna fuse right onto there, that pin there. Get it into place. Oh, so much thermal energy. I need to get this wire down and around. I want it to connect to the same ground point as the artificial center tap right on this tube here. Need to make a hole. All right, let's get that into place. We're pretty much using every pin on this socket. 2 signal input, 2 signal output, 2 power, ground, and trigger. 8 pins. It's a good thing I got a base from an old EL34 that has all the pins. A 6L6 would have been missing a pin 1 and possibly even a pin 6. All right, let's solder that on. There it is. So we got the 2 heaters connected there, heater line. This goes above. Right? I'm trying to keep it away from the signaling down here. So it's gonna go above near the bottom of the chassis and then boom, taps off power there. Then there's a ground wire hidden, that black one right there. It's gonna come around and go over to grounding over here. So this guy is ready to take a module now. As soon as this module is complete, I plug it right in and it should work. Now, relays are subject to controversy. I am questioning how much snap, crackle, and pop we might end up getting. Last time I used a relay for audio switching, it's switching an input signal. That's rough, bud. What are the chances that's not gonna chuck down the line and I'm gonna have to do some more figuring out? But now, our glue gun should be ready. If it's not, need a better glue gun. So we just take that hole, fill it with glue, take our guy, jam it in there. Just like that, bud. Just like that. Because this thing doesn't really create heat, it should be okay. We just gotta give the glue a moment to cool. So the question is, can we fish some of these wires down their holes now? Oh, those are easy. I'm gonna do the signal lines first because they need a bit more contortion. So they just pop right through, just like that. Let's get the front signal lines. Oh, come on now, keep it moving. Oh, it's binding up this one. Panic, panic. Come on, go through your hole. It frayed a bit. Oh, why don't you just go through your hole? There we go, we got it that time. All right, those are the hard ones. It's all downhill from here. Confirm black wire, yes. Oh, we got another binder. There it goes. And now the power lines. Starting to get excited. Last one. Oh, another binder. Come on, bud, just go, just go. You're the last one, man. You're the last one. Oh, there we go, got it. All right, look at that. Look at them all sticking out there now. So you know what we do? We secure it down, and now we solder those wires into the pins. Get the pin in the wire, nice and hot, and wick in the solder. Try not to get too much solder globbing on your tip. Okay, chop off the access. Inspect the pins for loose solder, and this thing should go in now. Hey, why is it a tight fit? Double check these pins. There it is. All right, what do we have here? Powered up. We got yellow light. Oh, shit. Oh, why aren't you triggering? Okay, well, if I grab chassis and I touch pin, whatchamacallit, nothing. Houston, we have a problem. Oh, what's going on here? Something ain't right. Huh? I don't understand why this is waggle pussing like that. Troubleshooting. Troubleshooting is always a great time. Oh, I'm derping out awfully hard here. It can't work without the DC regulator in place. Derp. Oh boy, the DC regulator has the artificial grounds. Huh. Okay. Okay, it's working as it should now. And then that means if I connect a ground and stick it on pin 8, or not pin 8, whatever, it'll be foot switch ready unless I press the manual button, then it's bypassed. All right, let's see if it works. Actually works. Let's see if it's gonna make big popping and clicking and popping and popping and popping noises, eh? Yeah, bud? Well, we gotta make sure. We gotta make sure. Where's our tubes? Oh boy. And will it get noisier because we have more exposed wire? Will connection to the relay compromise the signal integrity? Am I too far from the mic? Okay. There's a little hum. I don't know, it's much more than it was before. Bypass works. There's a little bit of popping action. I guess we'll have to solve that. Did I wire this relay wrong? Oh, it's always an adventure when you're trying to do weird stuff. Continuity tester. What say you? Continuity there. That signal should pass right through. Something else has gone wrong here. There was something touching. Oh no, it's more buzzy now. Oof. Oh wait, is it more buzzy because I didn't put this on? Nope. And it sounds worse. It's more buzzy, and it sounds worse. Did I accidentally screw something up here when I was poking around? Because I noticed this guy was out of place. Maybe we shouldn't have DC regulation right next to our signal. Well, on one hand it works. And it works pretty decently. The pop isn't too obnoxious. On the other hand, we've made it noisier. It was pretty quiet before, but now it's kinda... Well, not every story's a success story when you're a mad scientist in your lab trying to figure things out and make things do things maybe, well, I'm not gonna say they're not supposed to do. I designed it to do what it's doing, but it looks like I have some kinks to work out. Wait, hold up, hold the phone. I fixed it, or mostly. Anyway, there were two major flaws with the design. Ugh. Yeah. I, rerouted the switching on the relay unit itself. Before, we had signal coming in, and then going through the tube, and then signal coming back out. And so basically, this was compromising my signal integrity. It seems that relay isn't the best suited for signals. Maybe that warrants a bit of an upgrade. I don't know, but either way, I rerouted the switching like this. The input signal is going directly to the tube and is always connected directly to the tube, and then it passes back out. Now when I kick on the relay, all it simply does is select the output signal from tube to direct. So there's still just a little bit of interference because we have wires peeping up outside of the chassis into that relay module. But we've managed to bring the noise floor a lot better back down. The second thing, the biggest cause of the hum, was in the power supply circuit. The fact that there was a power supply circuit right here, right close to all the signal switching. We had to eliminate that. There's no longer rectification going on here. This diode has been eliminated and directly bypassed. And instead of running AC, well, we take that nice pure filtered DC I got there off that regulator module and we put that to it instead. And that made a massive difference. Massive, bud. It went back to sounding pretty good and normal, and lots of the noise went away. A lot of it. It's still just a touch noisier than it was before, but it's way better. It's more similar to what it was before. We further augmented things just a little bit by here. You can see I've added a piece of shielded cabling, and then on this side, you know, I put a little piece of tin, fashioned it into a shield, grounded it out, just to kind of, you know, keep that protected. Now the hum that I'm getting now, I don't know if it's necessarily related to the shielding interference now anymore. This should be doing significantly better jobs, but either way, it's better now. I also went ahead and installed the foot switch jack. Very, very simple, because a relay works by referencing ground, just simply taking chassis ground, and that signals the transistors what to do. We just needed but the one wire going to the signal pin on the relay module. And now she's done for now. We're gonna call it good until I'm prepared to put together another iteration. Let's go hook it up. All right, if you can hear that, we got a bit of hum and hiss. Does it go up and down with the volume? Well, yeah, it does, but still way better than it was. Considering I'm only gonna be using this for, you know, really noodling around in my room, I think it's gonna be just fine. Now, of course, we're not done yet, right? So. Oh yeah, the rerouting got rid of most of the popping noise. There's just like a subtle little bit when you turn it off. Yeah, look at them blinkers. Look at them blinkers, bud. Okay, so that turned out good in the end, or at least I think it turned out pretty good. For a first revision, you know, I've been working on the tube amps for a while, but switching is still something I'm a little bit getting used to, trying to get all those relays and whatnot synchronized so that they don't make pops and they're transparent and they work fast, and that's something I've been doing a lot of research into recently. That's the reason why I've been playing around with so many of these transistorized buffered circuits. get this out of here now. So, I still have other stuff I want to do to this. Voicing, adding a volume so I can tweak on the gain structure, adding a tone knob so I can tweak a little bit, dial in a little bit more warmth, all sorts of things. So stay tuned and find out what I do to this thing next. And this video is like 6 hours of footage. Great.